we will discuss the last topic of the physics syllabus, that is atomic structure. But see, it may be the last topic that I will discuss, but now actually the first topic begins from your point of view. Because now you have to solve all the questions and everything, and you have to accelerate your study process. Day by day your acceleration should increase. Okay. Now, the atomic structure. We know today that in the central part of an atom there is a positively charged nucleus which contains almost 99% mass of the atom, and around that nucleus in different orbits there are electrons revolving around the nucleus in the atom. So this electronic structure is generally called as atomic structure. And why the electrons are not leaving from the nucleus? Because they are attracted by the force of Coulomb force given by the positively charged nucleus. Now, when this model of the atomic structure was first given by Rutherford, and in Rutherford model, previous to that there are more models like palm-pudding model by Thomson and all these things. But first the complete model comes through Rutherford's model. Rutherford model says that positive and negative charges are not distributed throughout the nucleus by forming a homogeneous mixture. Because in the palm-pudding model it is considered that positive and negative charges are spread throughout the atom and they are producing a homogeneous mixture. But if that is true, then each portion of the atom must have same density. There will not be many vacant space in the atom. But we know that most of the mass is concentrated near the nucleus. The structures are almost vacant, only carrying the electrons. So this palm-pudding model is not correct. Rutherford model says that the entire mass of the nucleus with all its positive charges will be concentrated nearly at the center, and there are different circular orbits in which the electrons revolve around the nucleus. Now, there is a problem in this model because we know that if the charged particle is moving in a circular path, then it is actually performing accelerated motion because its direction of velocity is continuously changing, so the charged particle gets acceleration towards the center, called the centripetal acceleration. Now, due to centripetal acceleration, charged particle will radiate electromagnetic wave. So electromagnetic energy is continuously radiated from the charged particle, and as a result, the charged particle's total kinetic energy will decrease. So its velocity will decrease, magnitude of the velocity will decrease, and the path will be like this. This is the positively charged nucleus, and electron's path will be like this. Spiral shape, and electron will fall on the nucleus. And then when electron will fall on the nucleus, because similar number of electrons and similar number of protons are present, so all positive and negative charges will combine to produce zero charge, and that is a complete destruction of the electronic structure. Clear? But we know that this electronic structure is very stable. Electrons normally will not fall on the nucleus, but the Rutherford model cannot explain this phenomenon. Okay. When Rutherford student Niels Bohr produced another model, The model is that electron cannot revolve in any arbitrary orbit around the nucleus. There are some specific orbits. There are some specific orbits in which electron can revolve around the nucleus. And there is a special property assigned to the orbits that whenever the electrons are in these special orbits, they will not radiate any electromagnetic radiation during their revolution around the nucleus. Now, many one of us will ask the question that electrons in revolving, it is moving with centripetal acceleration, but Bohr model is saying that in this orbits, if electrons still moving with centripetal acceleration, they will not radiate energy, electromagnetic radiation. How can it be possible? Okay, this one is not only our question, this one is also the question given by asked by Einstein. Einstein said Bohr that when Bohr said that electron will jump from one orbit to another orbit, Einstein in front of the whole scientific community in a conference asked Niels Bohr that, and so according to you, electrons are like monkey. It is jumping here and there. And due to this controversy, there is a very cold relation between Einstein and Niels Bohr throughout remaining their lives. There are very cold relations. They are not liking one another. Okay, but the thing is that Bohr considered something peculiar, but that is actually true. Bohr considered something peculiar, that electron can jump from one orbit to another orbit. Between the two orbits, how electron moves from one orbit to another orbit, that is unknown. Electrons in that particular orbit, while revolving, they will not radiate electromagnetic radiation, but almost all are true. Partially true, not completely, but partially true. Now, why this kind of situation generates? Because at that time when Niels Bohr proposed this model, quantum mechanics is not developed in its full format. Today we know that quantum mechanics is a developed branch, but in those days only the early quantum theory given by Max Planck and given by Einstein in explaining photoelectric effect, probably only these theories are there. These are called the early quantum theory. The entire quantum mechanics was not developed at that time. So that's why when Bohr first uses these quantum ideas, everybody was it was very annoying to everyone that how these miraculous things will happen in case of an electron, which was at that time believed as just a particle. So since it was believed as just a particle, people thought that it will obey all the behavior as predicted by Newtonian mechanics or predicted by Maxwell's electromagnetic theory. Any new phenomena can occur or not with the electron that is completely unknown to the scientific community at that time. Now, what Bohr proposes? Bohr proposes two things that is called Bohr's postulate. First one, angular momentum. First, it says that electron cannot stay in any arbitrary orbit, or electron cannot revolve in any arbitrary orbit. There are some specific orbit. Bohr called it stationary orbit. So there are some stationary orbits in which electron will revolve around the nucleus. So first thing that Bohr proposes is the idea of stationary orbit. Stationary orbit. Okay, stationary orbit means if the electron is there, electron will not revolve and not radiate any electromagnetic radiation. Number 2. The natural question comes, how to specify those stationary orbits? Means which orbits are stationary? The orbits in which angular momentum of the electron is an integral multiple of h by 2 pi. It says that those orbits are only stationary orbits in which, while revolving, angular momentum of the electron NDR will be equal to n times h by 2 pi. Means integer multiple of h by 2 pi. So minimum angular momentum can be h by 2 pi, and it should be an integer multiple, that is 1h by 2 pi, 2h by 2 pi, 3h by 2 pi, like this. N cannot be a factor. Means it specifies the orbit. All orbits or any radius orbit is not possible. Some particular fixed orbit are possible. Those are called as stationary orbits. Now, natural thing comes, how Bohr got this relation? How Bohr got this relation? Next, Bohr considers another thing and actually influenced by Max Planck idea. He considered that whenever the electron jumps from any higher orbit to a lower orbit, it will release some energy. And when the electron jumps from lower orbit to higher orbit, it should absorb energy. And if you calculate the difference of energy E2 minus E1, or better to write EI minus EF, EF minus EI, suppose, then it should be integral multiple of h nu. It should be integral multiple of h nu, because energy is considered as quantized and they are like energy packets having energy h nu, and it should be in integer number of packets. Okay, as Max Planck considered that black body radiation energy is emitted like quantum nature, h nu is the minimum packet of energy. Einstein considered the same thing in explaining photoelectric effect. So both consider same thing. So if it is going from 1 to 3, then it will be 2 h nu. 1 to 4, then it will be 3 h nu, like this. So both consider all these things. Now, this one is actually influenced by Max Planck hypothesis, but how Bohr got this one? That was also influenced by de Broglie's wave, that is matter wave. So he considered that Bohr thought that inside the atom, electrons probably behave like wave, not like a particle. So we can associate a matter wave as predicted by de Broglie to the electron when the electron is revolving inside the atom. So Bohr considers that suppose this is one orbit. Bohr considers circular orbit. This was one of the fault of the Bohr model, that Bohr considered the orbit to be circular. The orbits are not actually circular, they are elliptical. So first Bohr considered circular orbit, and he considered that each electron, with each electron, there is an associated de Broglie weight or matter wave associated with matter wave de Broglie wavelength lambda. We'll consider that with each electron there is an associated de Broglie wave whose wavelength is lambda. Okay. So for a single electron, how to represent the de Broglie wave? This is the entire wave, and say this is the electron. This is the entire wave. Means complete wavelength having length lambda. Complete wave having length lambda, that is the wavelength. Now, how much length this wave will occupy? Lambda. This wave will only occupy a length lambda. Now for consider, suppose there are 1 electron, 2 electrons, 3 electrons, 4 electrons in the orbit. Now 4 electrons, how much length their wave will occupy? 4 lambda. If there are n electrons in orbit, how much length those electrons will occupy? Their waves will occupy n lambda. So board considers that if in a orbit there are n electrons, then we can consider n lambda will be the length occupied by the electron waves. N lambda will be the length occupied by electron waves. And if this particular orbit has radius r, then what is the length available in the circumference of the orbit? 2 pi r. So go equate this to and write 2 pi r will be exactly matching with n lambda. So 2 pi r is the available length in the circumference of the orbit where the electron stays. Each electron is occupying a length lambda, means electron wave is occupying a length lambda. So n number of electrons wave will occupy a distance of n lambda, which should be equal to 2 pi r. Then use the de Broglie relation here to write lambda as h by mv. H by p, p means mv, right? So it will be 2 pi r equal to n h by p. P means mass into velocity. And immediately you will get mvr equal to n h by 2. That is the Bohr's quantum condition. That angular momentum relation is written by Bohr. So from this logic, by considering de Broglie wave, Bohr arrived at the result of mvr equal to nh by 2 pi. Okay. The n is called principal quantum number. So it should be an integer. And how these electrons are occupying in the orbit? Like this. Like this. Now, in the Bohr model, it considers the quantum nature of angular momentum of an orbital electron. It also considers the quantum nature of the energy emitted due to the transfer of electron from one orbit to another orbit. Both are quantum nature are considered. But still, Bohr model cannot explain all the phenomena of the atomic spectra. Why? Means there should be certain demerits or certain fault in the Bohr model, due to which Bohr model cannot explain all the phenomena observed in atomic spectra. Even for hydrogen spectra, there are certain situations where Bohr model fails to explain hydrogen spectra properly. Can you identify where are the problems in the Bohr model? Write down. First one. Sometimes question comes that identify the fault in the Bohr model. Suppose 4 options given. First one. Consideration of circular orbit. Consideration of circular orbit. That is one of the fault, because electrons are moving actually in elliptical orbit. Okay. Number 2. No information about spin quantum number of electrons. No information about spin of the electrons. No information about spin of the electrons. Today we know that there are 4 quantum numbers. One of the quantum number, last invented quantum number is spin quantum number. So at that time of Bohr, it was not considered anything like electron spin. Up spin or down spin, that is not considered. That is another fault. Okay. Then number 3. Considering only electrostatic force, considering only electrostatic force between proton and electron, only electrostatic force between proton and electron, because when you will see the Bohr model's calculation in your book, you will find that it is considered that electron in the orbit is experiencing a force provided by the nucleus, that is electrostatic force, and we equate this force with mass into centripetal acceleration. Now from this calculation we proceed for the Bohr model, which the basic equation is not correct completely, because electrons are not at rest, even protons are not completely at rest. As a result, you cannot consider only electrostatic force between proton and electrons. Since electrons are orbiting, they are producing magnetic moments. So all these are not constant. So magnetic field is developed inside. Even inside the nucleus, neutron and protons are converting from each other, means there is an apparent shift in the position of there is an oscillating proton inside the nucleus, but due to oscillating proton there should be some magnetic field of the protons. So electrons is not moving only under electrostatic force, it is also feeling magnetic force, and nothing is considered. So these are the major faults of the Bohr model. These are the 3 faults, and now the 4th and the most major fault will come, which was later corrected by Sommerfeld. That in a stationary orbit, to Bohr, in a stationary orbit according to Bohr, position and linear momentum can be measured simultaneously. Position and linear momentum of the electrons can be measured simultaneously. Which is not correct because of uncertainty principle. Because of the uncertainty principle, this is not correct. So, in a stationary orbit, you cannot measure the position and momentum simultaneously. Okay, so these are the major faults of the Bohr model. That's why Bohr model cannot explain certain things, because you know that Bohr model cannot be applied, can be only applied to hydrogen or hydrogen-like structures. Means singly positive charged helium ion. For this model can be applied. Singly positive charged lithium ion. So for this we can apply. But for helium, lithium, for many electrons, many electrons atom, we cannot apply. For single electron structure, we can apply. Single electron means either hydrogen. Single electron means helium single plus, not 2 plus. There are 2 electrons. Lithium single plus. So in this lithium 1 plus for this. So there should be only 1 electron atom. In that case, Bohr models can be applied, or any ions considering having only 1 electron. Any ion having only 1 electron, you can apply Bohr model. So hydrogen or hydrogen-like structure. Okay. Now, if you place hydrogen spectra in a strong electric field, normally when we get hydrogen spectra, it will become a band spectra. Means some yellow zone, some red zone, some bands will be formed. There are some invisible portions also from the electromagnetic, that is radio wave zone, that is ultraviolet zone, then the radio wave zone, the infrared zone, and all these things. All the light electromagnetic spectrum we cannot see, we can only see the visible spectrum that belongs from the Bauma region, Bauma spectrum. Okay. Now, in this Bauma spectra, even if you observe, you will see that there is a violet zone, then there is a blue zone, then there is yellow, green, yellow, orange, red, this type of zones you will find. But this much thick zones you will find. These are called band spectra. Now, if you put this hydrogen atom in a strong electric field, very strong electric field, and now this effect is called Stark effect. S-T-A-R-K. Stark effect. Write down. Fine structure splitting of hydrogen spectra. Fine structure splitting of hydrogen spectra in presence of strong external electric field. In presence of strong external electric field is called Stark effect. And fine structure splitting, again write, fine structure splitting of hydrogen spectra in presence of strong external magnetic field, strong external magnetic field is called Zeeman effect. Zeeman effect. Okay. Bohr model cannot explain these two effects. Bohr model cannot explain these two effects. Means Stark effect, Zeeman effect, neither can be explained by Bohr model. Okay. Now, here we got that angular momentum of an orbital electron is integral multiple of h by 2 pi, that is quantized. Earlier we used this same Bohr model in case of finding the magnetic moment of the orbital electron, which is integral multiple of Bohr magneton, h by 4 pi m, Bohr magneton. Okay. Now we got that angular momentum is quantized. Earlier in when we are studying the magnetic moment of an orbital electron, magnetic moment of the orbital electron, we use the same expression. Use this result to find that. Now, so these models are given. Now not only angular momentum is quantized by Bohr. When Bohr quantized the angular momentum and energy, many things will become quantized in the calculation. What are those things which becomes quantized? Radius of the stationary orbits are also quantized. Radius of the orbit is also quantized. Velocity of the electron, means speed of the electron in a particular orbit, is also quantized. So in a particular orbit, electron cannot have different speed. So and in two different orbits, electrons will not have the same speed. They are moving at different speed. The radius of the orbits are also quantized, and all this will come from Bohr's theory. Though it's not a completely correct model, it has many fallacies, but still it is the first model to by incorporating the ideas of the quantum nature. So that's why this model is still yet discussed, and as a syllabus, in a syllabus and curriculum, this model is emphasized. Now, is this model quantum model? This model is not complete quantum model. It is called a semi-classical model, because somewhere classical mechanics is considered, somewhere quantum ideas are considered. So it is a bit of mixture. So it is called a semi-classical model. Now, why not complete quantum model? Because you have heard about the term quantum mechanics, definitely. And in quantum mechanics, that is peculiar branch, in which there is no concept of force, no concept of velocity. In classical mechanics, you know that there are the concept of force and velocity. These are, you cannot change this concept. So in case of quantum mechanics, you don't have the concept of force, you don't have the concept of velocity and all these things. So that is a peculiar branch. So that's why this model more consider the concept of force, concept of velocity. So it is not a complete quantum model. Another branch is there. Can any one of you say where the concept of force is changed by saying that force is not at all present, it is only geometry? It is only geometry, force is not required. Suppose you are on the top of it, inclined, smooth and released. In which direction you will move? like this. Can you move in the other direction? No. And it is said that in this way that since the surface is like this, you are bound to move like this. If the surface is changed, your motion will be changed. So no force is not at all required. Since the geometry of the surface dictates you to go like that, you will look like that. You move like that. So there is no force actually. Everything is the geometrical structure through which we are moving. That is said by, not only said, it was proved by Einstein in his general relativity by considering that there is no force called gravity. Gravitation is not a force. It is merely creating a geometry of the space and time. This geometry is so, that's why all stars, all planets, everything are following that geometry and rotate. There is no such centrifugal force or anything. But we are not in that position. Einstein can say anything. But if we write all these things, and we will get a big zero. Okay. So in the Bohr model, we consider that there is an electron here. The radius of the orbit is considered as r, and we consider there is a proton. The proton's charge is plus e, and let us consider it is a hydrogen-like structure such that I will write z number of protons are there, plus z. Because if I consider single hydrogen, then I will not write any z. Z is the atomic number. So hydrogen-like structure, that is helium, lithium, I can put Z equal to 2, Z equal to 3 like this. For hydrogen I can put Z equal to 1. So I write the general form. Now in this case, this is the orbital electron with charge minus E. It is moving, and we consider in a particular orbit speed is constant, and that is v. So we are considering according to Bohr that electron is performing uniform circular motion. Now in this uniform circular motion, according to our classical idea, there is a force acting on the electron which pulls the electron towards center. Which force? How many forces are acting on the electron now while orbiting in around the nucleus? How many forces are there? What are those forces? 10? 10. What are those forces on the electron? You have to count. What are those forces? 2. What are those forces? Electrostatic force. In which direction? Which gives? Electrostatic force given by some other agency. Centripetal force can give electrostatic force, that cannot be said. Electrostatic force is given by protons. Then other force is tangential force. We are considering uniform velocity, uniform speed, means there is no force in the tangential direction. Otherwise, uniform circular motion will not be performed. How many forces? One is said electrostatic force on the electron given by nucleus. Then other force? Centripetal or centrifugal? The answer is no other force. Only this force is responsible for the motion. Only this force is responsible for the motion. Now, from where we want to observe the motion? Sitting on the electron or sitting outside the electron? Sitting outside the electron. If you prefer to sit outside the electron, you will find only one force, and that is electrostatic force, denoted by F. Direction is already denoted. Now, don't say that there is another second force, centripetal force acting on the electron. Then I will ask what exerts that second force. Then you will again say nucleus. I will say that nucleus being a positively charged force, it cannot give two different forces, one centripetal and one electrostatic. It will give only electrostatic force. This electrostatic force produces centripetal acceleration. So don't call the term centripetal force. This is a misnomer term. This force will be simply equal to mass into acceleration, but the acceleration is v square by r, the centripetal acceleration. Okay. So Newton's law, second law, that is force equal to mass times acceleration, that we have written. So don't say centripetal force is another force acting on this. There is not two forces, there is only one force. We generally say that that force which is responsible for producing centripetal acceleration, we are eager to call it centripetal force. That's why this force F is playing the role of centripetal force. Centripetal force is not a different force. Electrostatic force in this case is playing the role of centripetal force. Okay. So better to say no centripetal force. This electrostatic force will produce centripetal acceleration. Simply write force equal to mass into acceleration. Now, I can write then mv square by r equal to 1 by 4 pi epsilon naught E square Z square by r square. Total number of charge in the nucleus is considered class Ze. So class Ze into E will be Ze square divided by r square. So this is the Coulomb force. Q1 Q2 by r square. Now cancel 1r from this. Then we can write mv square will be equal to 4 pi epsilon naught. mv square will be equal to 1 by 4 pi epsilon naught Z square by r, and multiply both sides by half. So it will be Z square by 8 pi epsilon naught r. Z square by 8 pi epsilon naught r. Okay. Now, this is the kinetic energy of the orbital electron according to Bohr model. So this is equation 1. Now we consider that electrons have some potential energy, electrostatic potential energy. So what is the amount of that electrostatic potential energy? So this one is kinetic energy, electrostatic potential energy. We denote it by Q, capital V. that we can write directly, that is minus z square by 4 pi epsilon naught r. This is the electrostatic potential energy of the electron. Means 1 by 4 pi epsilon naught q1 q2 by r. This is the form of electrostatic potential energy. q1 is Zd, q2 is minus E. So it will be minus Zd square by 4 pi epsilon naught r. Okay. Kinetic energy is half mv square. That is coming Zd square by 8 pi epsilon naught r. Potential energy is minus Zd square by 4 pi epsilon naught r. So if you calculate the total mechanical energy, total mechanical energy denoted by E, and that is equal to kinetic plus potential. So if you do this calculation, you will get minus z square by 8 pi epsilon naught r. This is the total mechanical energy of the electron. I add simply equation 1 and 2. It will be minus z square by 8 pi epsilon naught r. Because see, z square by pi epsilon naught r, that is common. In the kinetic energy expression there is 1 by 8. In the potential energy expression there is minus 1 by 4. So 1 by 8 minus 1 by 4 is minus 1 by 8. Okay. So it will be minus z square by 8 pi epsilon naught r. Now, so this is the expression for kinetic energy that we have derived. Now with equation 1 and 2, 1 and 3, we will discuss certain conditions. With equation 1 and 3, and we apply both hypothesis of both postulate for angular momentum to show the quantization of radius of the orbits and quantization of energy. Clear? See. From equation 1, I can write mv square equal to z square by 4 pi epsilon naught r. Check. By cancelling that 2, I can write mv square by 4 pi epsilon naught mv square equal to z square by 4 pi epsilon naught r. Then I multiply both sides of this equation by m square, by m, another m, and r square. I multiply both sides of this equation by mr square. Okay, so write down, multiply both sides of the equation with mr square. Multiply both sides of the equation by mr square. What you will get? M square, d square, r square will be equal to z square m divided by z square m by how much? 4 pi epsilon naught, and there is 1 r. one r will be there in the numerator. Because I multiply both sides by mr square, so it will be m square v square r square equal to z e square mr divided by 4 pi epsilon naught. Because r square is there, so one r will cancel, it will become r. Okay. Now we know that mvr equal to nh by 2 pi. So I can write here directly. It will be n square h square by 4 pi square. N h by 2 pi is square. So it will be n square h square by 4 pi square. That is coming z e square m by 4 pi epsilon naught. But now it should not be r only. Suffix a. Because see, other terms in the right side, z e n 4 pi epsilon naught, all are constant. Only variable is r. So r should vary with n. Means n is taking only integer values, so r will have some definite value. Not an arbitrary, any arbitrary radius electron cannot stay. The stationary orbit cannot have any arbitrary radius. Their radius is quantized and guided by this principal quantum number. Now, how? So the quantities that can be cancelled, first this one pi will be cancelled, other terms will not be cancelled. So we are getting the expression for Rn. Rn should be equal to what is coming? Rn equal to, so n square will be there, then epsilon naught h square divided by z e square pi n. N square epsilon naught h square by z e square pi n. Right? So it shows that Rn is directly proportional to n square. So orbits are not equispaced. Orbits are not equispaced. It varies with n square. So between first orbit and second orbit, there is a certain gap. Between second orbit and third orbit, gap is larger because radius varies with n square. So as you are going to the more and more higher orbit, the gap between two successive orbits will increase. Now we can write this expression as Rn equal to n square by z e naught. N square by z e naught. Remaining constant is considered as e naught. Okay. N square by z e naught. Remaining constant means epsilon naught h square by e square pi n. Now if you put z equal to 1 and n equal to 1, you will get R1. R1 equal to A0, first Bohr orbit, first radius of first Bohr orbit, that is nearly 5.3 into 10 to the power minus 11 meter. 5.3 into 10 to the power minus 11 meter. First board orbit radius. I write the general form such that hydrogen-like atoms can be accommodated in the calculation. If you are calculating only for hydrogen, simply you can put Z equal to 1. Okay, simply you can put Z equal to 1, and in that case, for only hydrogen atom, it will become Rn equal to n square A0. But I consider the hydrogen-like atom, that is lithium ion, helium ion, all can be treated with this formula. By putting the value of Z, for helium it is 2, for lithium it is 3. Okay, so this is the format of Rn. So you have to remember only this one. You have to remember only this one and the value of A0. Because otherwise in the exam, if you try to put the value of epsilon naught, h square, e square, pi, n, all these things, then you cannot complete the calculation within the time. Because it will be too long values and it will be very difficult to calculate. So remember the formula for value for A0, and that formula Rn equal to n square by z A0. You can solve any problem by varying the values of n and z. Okay, now if I get this value of R, then I can substitute this value here. Then what it gives? So I will start here from that expression and then define the quantities. So it should be E equal to minus ZE square by 8 pi epsilon naught into 1 by R. So from that expression, write 1 by R. From that expression, don't write that. From that expression, 1 by R means it will be ZE square pi n divided by n square epsilon naught h square. Z is square pi n by n square epsilon naught h square, because I have to write the value of 1 by R. Okay. Then since there is n, now we can consider this E is also quantized. E is depending on n. Then it gives you En equal to, now it is divide, 1 pi will cancel. So 1 pi will be cancelled. Any other thing? Other things are not cancelled. So it will become e to the power 4 into m divided by 8 epsilon naught square h square. See, z square is taken out, n square is taken out, then inside bracket there will be e to the power 4 m divided by 8 epsilon naught square h square. Here. Now, this entire quantity has a value minus 13.6 electron volt. Minus 13.6 electron volt. You have to remember this value. Okay. Then you can write En as minus 13.6 z square by n square electron volt minus 13.6 z square by n square electron volt. For hydrogen, in the first Bohr orbit, the hydrogen, if the electron is in first Bohr orbit, z is 1, n is 1. So it will be minus 13.6 electron volt. In the higher orbit, for hydrogen, you can put z1 always for hydrogen, and n will be 2, 3, 4, etc. Principal quantum number. So it shows that as you are going to higher orbits, energy will increase. There is a minus. Okay, so first one is minus 13.6, next one minus 5.6. So it is increasing, going towards 0. So don't say that divided by n square means it will decrease. Its numerical value decreases. Since it is negative, it will actually increase. Okay. And for other atoms, you can vary. For helium or lithium ions, you can vary Z as 2, 3, and you can find all these calculations. Now see, here from this calculation, if I put here R as this quantized value, then I will also get V also quantized. So V is depending on N also. So you can also find that relation. That V is how V is depending on N. Okay, and it clearly shows that R is directly proportional to N square. So if I put here R directly proportional to N square, so V will be proportional to 1 by N, because there is a N square because of the R directly proportional to N square. So V square is there. So if I calculate root, then V is proportional to 1 by N. So as the number of principal quantum number increases, so the orbits are far away, the velocity will decrease. N increases means velocity will decrease. Okay. And velocity decreases means it is very easy to remove the electrons, because if velocity is more, that means centripetal force will be more, means attractive force towards the center is more. So as velocity decreases means it is far away from the nucleus, so the force, attractive force of the nucleus is not that much of strong. So it can be easily removed. So that's why electron can be removed only from the conduction band or in the chemical reaction from the valence band, not from the other lower orbits, because in the lower orbit nuclear attraction is too much. Okay, so this one is the entire Bohr atom model. After doing this, we are very bored, very much bored. So take a small break, and after that there will be that spectrum and all this portion, and then we will discuss some numerical questions. Then it will become E, suppose it is written as ENI, initial orbit, which is denoted by principal quantum number Ni. Then this expression will become, from this you can write Z e to the power 4m by 8 epsilon naught h square, e to the power 4m by 8 epsilon naught h square, m by 8 epsilon naught H square. This multiplied by epsilon naught square H square. This multiplied by Z square by H square. Z square by Ni square, accordingly I will write with the minus sign. Okay. Now, in another bored orbit, when the electron goes, this is denoted by ENF. So it will be minus Z square NX square into E4 N by 8 epsilon naught square H square. Okay. So when electrons are moving from one orbit to the another orbit, so it will release some energy from, if it is going from higher orbit to lower orbit. So let us consider EI is the some higher orbit, and now the electron jumps from higher orbit to lower orbit, so it will release certain amount of energy. So we can calculate that EI minus EF, sorry, EF minus EI I will calculate. Final minus initial. EF minus EI. What it will give? Means ENF minus ENI. Let us do it. N suffix F. Now calculate and tell me the form of ENF minus ENI. It will become Z square E4 M by 8 epsilon naught square H square into 1 by Ni square minus 1 by Nx square. Right? Okay. Now if I consider that EF minus EY I is an integral multiple of H nu, it can be written as like this. H nu, it can be written as Hc by lambda. Then I can write this one as Z square E4 M by 8 epsilon naught square H square into 1 by Ni square minus 1 by Nm square. Okay. Now we can write 1 by lambda equal to this Hc will be multiplied here, written as RH called Rydberg constant. Rydberg constant. 1 by Ni square minus 1 by Nx square. So the emitted wavelength can be calculated from this. Okay.
Rydberg constant is equal to only Hc or Rydberg constant.
R with only
RH is
you can maintain that, but then it will be reduced Rydberg constant. If you divide it by H, just like you can use reduced Rydberg constant. Okay. So entire value will be there, and you have to put that value. Remember that value of the Rydberg constant. Sometimes it is written, some book it is written that C is there differently written. Okay. Now, if in this case we consider that Ni equal to 1, then from Ni equal to 1, Nf can be anywhere. Ni equal to 1 we consider, and Nf is the final location. So any particular orbit, from that it can go up to infinity. Then it will produce, this can be 2, 3 and so on. Then it will produce a series containing wavelength called Lyman series. Lyman series. Okay. Then from Ni equal to 2 and onwards, it is called Baumol series. Then Ni equal to 3 and onward, first chance, bracket 1. So this 5 series for the hydrogen atom. Lyman series, Baumol series, Paschen series, bracket series, Hunt series. So similarly, Ni equal to 1 start means 1, 2 other or principal quantum, Nf equal to 2, 3, 4 and etc. It will produce Lyman. Then Ni equal to 2, 2, 3, 4, 5 etc. It is called Baumol and so on. Next we will start from 3, next we will start from 4, like this. From this equation we can find the emitted wavelength and can check in which domain it will lie. Only the Baumol series wavelength is visible. Other Lyman series is not visible because it belongs from the UV zone, and other series belongs from the infrared zone that we can earn also. Only the Baumol series portion we can see. Okay. That these are the atomic structures. Now some other things that we haven't discussed yet. The first chapter of class 11 that we haven't discussed, that is units, measurements and all these things. First thing is, 3 things you have to study from this chapter. One is units and dimensions. These things are very notorious and you have to remember. Dimensional formula and all this, some dimensional formulas you have to remember. One thing is significant figure, that is also quite natural, because significant figure means if you write point after the number, if there are zeros, then these zeros are not significant. Okay. But after point, if there is zero like this, so this zero is significant, this zero is non-significant in any calculation. That zero is non-significant. Before the point, zero has always significance. Okay. Now, another thing from this portion, that suppose you have given vernier calipers. You have used vernier calipers in class, practical in school. In vernier calipers, you can measure the smallest distance to be 0.1 millimeter. It is called the least count of the vernier calipers or vernier constant. Sometimes called vernier constant. Maybe the least count term you will find with a screw gauge or a spherometer. For vernier scale, it is generally termed as vernier constant, 0.1 millimeter. But now, suppose one measurement you find 5.6 millimeter, one measurement you find 5.5 millimeter, and one measurement you find 5.6 millimeter. Okay. Then, what is the average measurement? Because in a practical you have to measure the length, suppose thrice, and then you have to take the average for the better result. And just tell me what is the average. You have your tabs and you can calculate there over calculator. Calculate. Using the tab, calculate. What is coming?
5.5.
Okay. 5.5. 5.6. Okay. So many students do these things. In that calculator, they put the data like 5.6 plus 5.5 plus 5.6. It comes 16.7. Okay. Then they divide by 3 and they write like this. Average is 5.566. Many 6, as much more 6 I can write. They start to write like that. But this is actually a wrong measurement. Why? If you write more 6, because it will be a non-terminating, 16.7 divided by 3, the result will not terminate. So the students, some students are eager to write 5 to 6 decimal place. But that is actually wrong. Because if in the experiment in class 11, if you write, then you will get number probably. But in any other college or anywhere in higher classes, if you write this kind of a thing, then your marks will be deducted. The person who writes 5.6, he is getting actual correct. 5.6 is the correct only. Or 5 point, better to write, more better to write is 5.5. Now what? See, this data I am saying this is incorrect. I am saying that 5.6 is also not that much correct. Absolute correct measurement is this one. According to experimental technique, this is the most correct answer. Now what? See, first of all, experimental device that you have can measure only 1 decimal place after point. 1 decimal place it can calculate properly in millimeter. Then if you write 4 decimal place, means you are not using a vernier calipers, you are using some more subtle device which can even measure 0.0001 millimeter. So your experimental setup device has certain accuracy, and you are claiming more accuracy than your experimental device, which is not possible. That is coming because of the calculation in the calculator, since it is not terminating. So that will not help you to measure it properly with an experimental apparatus like vernier calipers. Okay, so you cannot claim accuracy beyond the accuracy limit provided by your experimental apparatus. Then in the significant figures, you cannot add those 666. Okay, so you have to restrict yourself to 1 decimal place. Now 1 decimal place is coming 5.5. Now if you consider 2 decimal place 5.6, and then you will say that okay, I will take it 5.6 because 56 is more close to 60. 56, if you consider this one, this 2 number, you will find that 56 is more close to 60 than 50. So you probably write 5 instead of 5.50, you probably want to write 5.60. Okay, because of this notion. But again, that is problematic. Why? Because to measure that whether it is it is close to 60 or 50, you have to write 2 decimal place, and 2 decimal places are not permitted by your apparatus. Your apparatus can only give the accuracy up to 1 decimal place. So you have to write 5.5. Though from a natural sense it seems that two values are 5.6, one value is 5.5, so the average will be close to 5.6. But since your calculations and are bounded by your experimental technique, so don't forget that you are bounded by the experimental technique of the vernier calipers. So you cannot write 5.6, because how you get 5.7? Once you measure these 2 values, then you will get that 56 is most close to 60, then I should write 5.6. But to observe that this observation of 2 decimal place, you cannot observe by using vernier calipers. So the answer will become 5.6 only, 5.5 only, not 5.6. Okay. Now this is one part. So whenever calculator gives so many places, don't write so many places, because those places are not the significant figures. So what are the significant figures in all this calculation? Only after 1 decimal place after point, that is correct value is 5.5. Clear? Now the other thing that we have to discuss from this, that is dimensional analysis and error analysis, a little bit of error analysis. Now what do we mean by dimensional analysis? Suppose using any dimensional analysis technique, you can calculate a dimensional formula or any particular formula of physical quantities. But you can check or you can deduce the relationship by using dimensional analysis. One such case is reduction of the time period of simple pendulum. Normally, we can consider that this is a simple pendulum. Suppose it is taken on this side and then it is released. We consider length of the simple pendulum denoted by small n, and we consider mass of the bob small n. We consider that mass of the bob small n and acceleration due to gravity g. Now we consider that time period of a simple pendulum. Let us denote this time period by small t. I can consider that it may depend on length of the mass of the bob. So I can write it may be m to the power x. I don't know with how much power of mass it is varying. So I put m to the power x. Then I consider t is varying with length of the cord. So we write l to the power y, because we don't know with L square or with 1 by L square with which it is varying. So we write L to the power y. Similarly, we can write T proportional to G to the power Z. Okay. G to the power Z. So we consider that probably these three factors, on these three factors, time period of a simple pendulum depends. Okay. Then I can write T proportional to m to the power x, l to the power y, g to the power z, and then T proportional to equal to some constant k, m to the power x, l to the power y, g to the power z. Now to find the correct formula for simple pendulum, I have to find the values of x, y and z. Okay, and that we can find out by using dimensional analysis. Okay, only the value of that constant k cannot be determined by dimensional analysis. So this is the limitations of dimensional analysis, that it cannot predict you the value of any constant. Now consider first, in this equation I will put dimension on both sides. This side is time period, so its dimension is time. So it can be written as capital T. Its dimension. Dimension is always written in hard bracket, so I write. So this is K. First term is mass. Mass is dimensionally denoted by m, so it will be simply m to the power x. Then length. Length is again L, so it is L to the power y. G is acceleration due to gravity, means L to the power minus 2. So it will be L to the power z into t to the power minus 2z, the powers of g. In place of g, write L t to the power minus 2, then whole to the power z. It will be L to the power z into t to the power minus 2z. Okay. Now on that side, write this one as m to the power 0, n to the power 0, t to the power 1. Because n to the power 0 means 1, n to the power 0 means 1, and t to the power 1 means t. And write this one as k times m to the power x, l to the power y plus z, y plus z into t to the power minus 2z. Okay. Done. Now from both sides equate the powers of m, powers of l, powers of t. So equating the powers of m from both sides, I can write that x equal to 0. Because power of m is 0, power of m is x, so x should be equal to 0. Because both sides should be dimensionally correct. This k is a constant, dimensionless, unitless constant. So other powers of because these are representing a physical equation. Physical equation has same unit or dimension on both sides. So the powers of m should be equal. Then powers of l should be equal, which will give you y plus z equal to 0. Because power of l here 0, on that side it is y plus z. So y plus z will be 0. Okay. Then come to the third. It gives minus 2z equal to plus 1. Minus 2z equal to plus 1 from the dimension of t. So we get x equal, z equal to minus half. And on putting z equal to minus half in second equation, y plus z equal to 0, I get y equal to plus half. Okay. X equal to minus, z equal to minus half, y equal to plus half, x equal to 0. Now you can put all these values in this equation. So t will become k m to the power 0 means m is not there, l to the power half, g to the power minus half means k equal to k times root over of l by g. In case of v means l t to the power minus 1 to the power w. Can I find the formula for simple pendulum? If yes, then how? If no, then also why? If yes, then how? And if no, then why? See how many equations you will get by equating the dimensions. 3 equations. Because power of n, power of l and power of t. You will equate from both sides. So this will lead you to 3 equations. And see, unknown quantities are w, x, y, z. 4. 3 equations, 4 unknown. It cannot be solved. Okay. If there are 3 equations with 4 unknowns, we cannot solve. So if you consider one more, then you cannot. Since you are equating the dimensions of the 3 physical quantities, you have to restrict the number of unknowns to 3. Otherwise, it cannot be solved. Now, so this is the dimensional analysis. Now, errors. Now, many times a very complicated formula is given, and from that error has to be calculated. But for the calculation of the errors, I will first give you certain numericals, and then we will come to the error analysis, the calculation of errors. So write down in measuring the diameter of a in measuring the radius, write down in measuring the radius of a circle, in measuring the radius of a circle, a student has done a mistake of 21%. 21%. What will be the error in the measurement of area of the circle? What will be the error in the measurement of area of the circle? If I say 20%, then calculation will be easier. Okay, you can take 20%. Then calculation will be much more easier with 21. So when you squaring and all these things you have to calculate. Student is doing a having a measurement of 20% in the measurement of radius. Then how much will be the error in the measurement of area? Kolkata, this DK Mehta and Rohit Mehta's book is this much thick for 11 and for 12, these two thick volumes. Oh, it is given Meghalaya edition. Number of pages are inversely proportional to distance. In the Kolkata chemistry, if you go, this book is this much thick. Class 11 book this much thick, class 12 book this thick. Or it is divided into two parts. No, single. For entire for class 11. Generally the books are this much for 11, this much for 12. See, first we have to consider that initially radius is r. Then corresponding to that there will be some area. Area will be A equal to pi r square. Okay. Now this radius is changed to suppose r prime. So r prime is r plus 20 by 100 r. 20 by 100 r, because it is changed by 20%. So 20 by 100 r means this is r by 5 actually. So it will become 4r plus r, 5r plus r, 6r by 5. This is the new radius. Okay. Now from this I can calculate pi r prime square, and then using the following formula for error calculation I can calculate. But I will put this in a different manner. So area will be changed to a prime, and I can write a prime will be pi r prime square. Okay. Since radius changed to r prime, area changed to a prime, and a prime will be simply pi r prime square. So first I will divide this a prime by a. It will become 6 by a prime by a, this will become r prime by r whole square. Okay. A prime by a equal to r prime by r whole square. Now from this we know that r prime equal to 6r by 5. So r prime by r will be 6 by 5. So I can write here a prime by a equal to 36 by 25. Okay. 36 by 25. Now we subtract -1 from both sides. Subtract -1 from both sides. So that is a prime by a -1 equal to 36 by 25 minus 1. What left side gives? It is giving you a prime minus a by a. That is changing area by original area. That you have to calculate for calculating the error. Equal to 36 minus 25 by 25. So 36 minus 25 means 11. Perfect. Now this quantity is called proportional error. Proportional error in measurement of area. First, initially this quantity A prime minus A, this is called absolute error. A prime minus A, this is called absolute error. But absolute error has a problem, because absolute error is not dimensionless. It has the dimension of area. Because you are calculating final area minus initial area, that will be in meter square, suppose. So it has unit dimension, so it is not dimensionless. Then we divide it by original area such that it will become dimensionless. So absolute error is A prime minus A. Then we divide it by A to make it dimensionless, which is termed as proportional error. Okay? Then multiply both sides by 100 to get the percentage error. So these are the terms, that is absolute error, proportional error, percentage error, all this. So it will become 44%. Okay. It will become 44%. Now, if it is said that the error is only 2% or 1%, then I can calculate the percentage error with very less amount of steps. In that case, you can write this formula, A equal to pi r square. Simply take logarithm on both sides. Log A will be log pi plus 2 log r. Then differentiate both sides, and you will get dA by A. Log pi is a constant, so its derivative vanishes. So 2 log r, its derivative will be dr by r. Then if it is given that 2% is the error, then means dr by r is itself 2%. So 2 into 2, area measurement error will be 4%. Yes, if you can see that area depends on r square. So if in an area measurement, if there is 2% error, then in area measurement, radius measurement there is 2% error, then in area measurement 2 times error will be occurred. But that can only be true if this error is very small. With 20% error, you cannot use this formula, because that will give you 40, which is actually 44. Because this differentiation we can do only when this dr is very small. So when 20% area is changing, means the difference dr is not very small. So you cannot apply the techniques of calculus. Clear? So if a large error is there, you have to calculate it algebraically. If the error is very small, you can apply calculus to find the error easily, because calculus gives you the answer within a moment. For this 2%, you don't need to calculate and all these things. Clear? So this is the percentage error that we have to calculate. Now comes maximum proportional error or maximum percentage error. Now let us consider you are using a simple pendulum device. You are measuring time acceleration due to gravity. You are measuring acceleration due to gravity using a simple pendulum. What apparatus should be given to you? One scale, such that you can measure the length of the cord. So let us consider that up to the entire cord's length can be measured by using the scale. No vernier calipers or no screw gauge is required for measuring the radius of the diameter of this small sphere. Only the scale is sufficient. Now we consider another thing you have to measure. You cannot determine G by measuring only length of the cord. You require a stopwatch such that you can measure the time period of oscillation. Because if T and L known, then we can find G. Okay. Now, we know that T equal to 2 pi root L by G. So from this I can take a square on both sides. T square equal to 4 pi square L by G. Then I can write G equal to 4 pi square into L by T square. Now from this I can measure. Clear? G equal to 4 pi square into L by T square. From this, by measuring L and T, I can measure the value of G. Now suppose it is given that the meter scale what is the least count of a meter scale? 1 millimeter, because it can read minimum of 1 millimeter. Now for a stopwatch, minimum of 1 second. Stopwatch can measure a minimum of 1 second. Okay. Now, how to find the maximum proportional error in the measurement? How to find the maximum proportional error in the measurement? Suppose you are doing a measurement by taking L equal to 100 centimeter and time period is taken as 3 seconds. Time period is taken as 3 seconds and this one. Even if some digital stopwatch is given, then it can measure 1/10 of a second. Digital stopwatch can measure. Suppose it is given that digital stopwatch, such that results will be more better. In that case, what happens? It will be 0.1 second. Up to this it can measure 0.1 second. Now with this precision, if you measure the G, what will be the maximum proportional error? See, first we consider that these proportional errors are very small, because if you calculate dl by L, that is 1 by 100. If you consider dt by t, that is coming 0.1 by 3. 0.1 by 3 means nearly 1 by 30. That is also very small. Since they are very small, I can apply calculus. Okay? Then from this formula, first take logarithm on both sides, log g. equal to log of 4 pi square plus log of L minus 2 log T. Now differentiate both sides. You will get dg by g equal to, first term will be 0, second term will be dl by L minus 2 dt by t. Now this is the actual mathematical expression, but this is not the maximum proportional error. Maximum error means the possibility of the error will be highest. And if there is a minus sign, and if you are doing mistake in both the sides, it may happen that they will cancel each other and you will get the correct value. But is it possible? From this result, some can argue that if I make a mistake of 4% in measurement of L, and if I can make a 4% measurement, a 2% measurement in measurement of time, then these two will cancel and my result will be 100% accurate. So doing wrong measurement, your result cannot be 100% accurate. So maximum error can be calculated by considering the mod value of all the errors, means all signs should become positive. Then this expression will give you maximum proportional error once you take mod value and add. Means you have to take it plus. Okay, that is the maximum proportional error. Now you can calculate. So this dg by g will be equal to dl by L. dl is least count, that is 1 millimeter divided by 100 plus 2 into dt is 0.1 divided by 3. Now calculate. This one will give you the proportional error, then multiply both sides by 100 will give you the maximum percentage error.
Least count is in millimeters. Least count is in millimeters and length is in centimeters. So unit
Length, sorry. Length is 100 centimeters, so it should be 1000. So it should be in same unit. So least count is 1 millimeter and length is 1000 millimeter. So now calculate this one. This one will give you maximum proportional error. Then multiply the result with 100 will give you maximum percentage error. Okay. One problem. Force on a particle varies with displacement as first two. Varies with displacement as f equal to x square minus 3x plus 2. What will be the minimum value of the force? What will be the minimum value of the force? What will be the minimum, not value, write down minimum force. What will be the minimum force? Part A, question part A, then part B. This is part A, then part B. What is the physical significance of this minimum force? What is the physical significance of this minimum force? And then part C. At which value of x this would occur? At which value of x this would occur? 3 is equal to 3x minus 3. Then df dx equal to 2x minus 3. Then you have to set df dx equal to 0. Then you will get x equal to 3 by 2, and then at x equal to 3 by 2 force will be minimum. So you have to put this 3 by 2 in the expression of the force to find the mean of the height. Calculate. Now say 2x is equal to 0. X will be 2x minus 3. Then x will be 3 by 2. So at this point, force will be minimum. So put this value 3 by 2 here. How we can that is 0. Suppose that x equal to 3 by 2. Right? Put this value of x in the expression. Changes the direction. So the last one, I will value of x. That is minus of the 4. You have to divide by the respective x. Then you have to say that dx is equal to 0. From that you have x equal to 3 by 2. Then put that 3 by 2 in place of x in this expression to find the minimum force. In this method, no, in this method, the modification square plus 2 minus x. Now x is equal to displacement position of that is a real number. So we can consider that displacement of this equation is square to so displacement means b square minus 4 is that square so it is 9 minus 4 this plus 4x. So 1 plus 4 Then after that, write x equal to 3 by 2. Then substitute in first derivative is 0, that corresponds to maximum minimum. So this value has to be substituted here to find the minimum. Check the problem out. Minus 1 by 4. Maximum minimum ना जाए. See, many of you uses maximum minimum technique, that some first calculating the derivative df dx. You said df dx equal to 0. Then the value that you get, you put this value in the expression for force. If we do not know maximum minimum, then how to solve the problem? Suppose we don't know maximum minimum. Then how to solve? Then you cannot differentiate. Suppose anyone who does not know differentiation, can't he solve the problem? See, I can show you two different methods to solve this particular problem without using calculus. Two methods are there. First method is, this force is given. Now, this is for a moving particle. Means that x is the position of the particle. Can the position of the particle be an imaginary number or complex number? It should always be a real number. Okay, fine. So I can write it in this fashion: x square minus 3x plus 2 minus f equal to 0. X square minus 3x plus 2 minus f equal to 0. Now since x is a real number, discriminant of this equation should be greater than equal to 0. Discriminant means b square minus 4ac. So what is b here? Minus 3. So b square means minus 3 whole square minus 4 into a is 1, c is 2 minus f. So it will be 9 minus 8 plus 4f greater than equal to 0. We can immediately write f greater than equal to minus 1 by 4. So minimum value of the force is minus 1 by 4. No need to do derivative and all these things. Minimum value of the force is minus 1 by 4. Greater than equal to means that is the minimum value. So first, show some respect to the Indian man who derived this formula. Sridharacharya, always looking for Newton and Leibniz to differentiate and all these things. Okay, now at which position it is that we can also find from this, because the minimum value of f is minus 1 by 4. If I put that here minus 1 by 4, I can find that x will be equal to 3 by 2. By solving this, I can get x equal to 3 by 2. Because if you put minus 1 by 4, then it will become a perfect square. It will be 2x minus 3 whole square. So 2x minus 3 whole square will come and it will become x equal to 3 by 2. The other method. Other method is a graphical method. See, This is x-axis and that is y-axis plotted f. F is plotted here. Now this is the equation y equal to x square minus 3x plus 2 like this, where f is like y. Then I want to factorize this term once and write it as x minus 1 into x minus 2. When the term factor? See, x square minus 3x plus 2 means if you do the middle term factor, it will come out x minus 1 into x minus 2. Okay. Now check what are the zeros of f. If you put x equal to 1, force will become. If you put x equal to 2, force will become. Okay. So I find those 2 points. If I put x equal to 1, suppose here, the force will be 0. If I put x equal to 2, here, force is also 0 at 1 and 2. Means the graph of f versus x will cut the x-axis at point 1 and 2. So if this point's coordinate is 1, 0 and this point's coordinate is 2, 0 because f value will be 0. Now this equation represents which type of graph? Parabola. Quadratic equation. You studied in projectile motion, then since quadratic equation is coming in x square, so the trajectory of the projectile is a parabola. And remember, parabola is always symmetric. In case of projectile, the vertical line, parabola is symmetric. But there is a difference with that parabola. Because in case of projectile, parabola is concave down. But in this case, parabola is concave up. How to measure? How to find that parabola is concave up or concave down? See, when you do the projectile motion, just check the equation of trajectory. It will be y equal to tan theta into x minus gx square by 2u square cos square theta. So square term's coefficient is negative. So when the square term coefficient is negative, parabola will be concave down. Here the square term's coefficient is plus 1. That is positive. So parabola will be concave up. So write it. In an equation of a parabola, in an equation of a parabola, if the coefficient of square term is negative, parabola is concave downward. Example, projectile motion. Okay. And if the coefficient of square term is positive, the parabola is concave upward. Right? Now, I can draw a rough graph of the parabola. These two values, this will cut, and parabola is always symmetric. Symmetric will be midpoint of these two. So the graph of the parabola looks like this. It is symmetric about the midpoint. This is the axis of the parabola. Okay. So where the minimum value lies for this parabolic graph? Here at the bottom. At this bottom, it has the minimum value because at this point value is higher, come to 0. positive, positive, positive comes to 0, then goes negative, negative, and here it will be minimum. Then again it starts increasing. So corresponds to which value of x the force has minimum value? So this value x is between 1 and 2. So I can consider, since it is symmetric and it is just the midpoint, so this value of x will be 3 by 2, means average of 1 and 2. So average of 1 and 2 will give you that point where the value of the force will be minimum. So we got 3 by 2. Now put in this equation out here, you will get minus 1 by. Now the crucial point comes. At this point you are claiming that it is minimum. Means I can draw a tangent at this point which will be perfectly horizontal. Because if it is not horizontal, then it cannot be minimum. Either it will increase on one side or decrease on one side. So minimum means it should be horizontal. What is the slope of a horizontal line? 0. And slope in calculus is written as dy dx. So when we use this dy dx, that is df dx here, you say that df dx equal to 0, means you are actually setting the slope of this horizontal line. So calculus is not a different branch from geometry. It is closely related to the geometry. Horizontal tangent means its slope is 0. That's why we consider the first derivative to be 0 to find that maximum or minimum value. Because if it is a maximum value, still the line will be horizontal, tangent line will be horizontal and slope will be 0. Then the second derivative has to be determined to find whether it is maximum or minimum. Okay. So any method you can adopt to find. Okay.